In this lesson, we will be graphing translations and reflections of sine and cosine graphs. So we need to take a look at the information for doing our transformations. So we have our basic function that we've talked about previously, and then we need to see what's going to happen to that. So with our basic function, we had y is equal to a times the sine of bx, or we had y is equal to a times the cosine of bx, where a is the amplitude, and then 2 pi divided by b gave us our period. So now what we want to do is to be able to describe what happens when we have those with our different amplitude or our different period, and then being able to shift those. So when we come into this format, what happens is when we have something added on to our function, the k, or the part that's added on, will shift those units vertically. So if this says plus 2, we would shift it up 2, and if it said minus 2, we would shift down 2. Then the h is what's going to shift our graph horizontally. And the format is minus h. That's actually our form. So if this said minus 2, that means the h would actually be a positive 2 and shift it horizontally 2 units to the right. If this said plus 2 in here, that would have made that a negative 2, shifting it 2 units to the left. The other thing to remember is if our a value is negative, that's going to reflect the graph over the y equals k line. And we will talk about the reflection, flipping it up or flipping it down. So let's begin with our first example. We have y equals 3 plus 1/2 cosine of pi x. Now if we put this into our form, that's a little bit easier to understand. We have 1/2 cosine of pi x plus 3. So our k value is equal to 3, and that means that we are going to shift our entire graph up 3 units, shift it vertically. Before we do that, we want to find out, first of all, our amplitude. And if you recall, our amplitude is the absolute value of our a. So our amplitude is going to be at 1/2. Our period, if you recall, is going to be 2 pi divided by b. And our b value is actually pi. So that makes our period to be 2. So if we start with our function to figure out what to graph, our x values, remember we were at 0, pi over 2, pi, 3 pi over 2, and at 2 pi. Then our cosine of x, we begin with our cosine value at being positive 1, back to 0, negative 1, back to 0, and to positive 1. So we'll use those basic functions to do our shifts and our transformations. So we'll start with our amplitude. So with our amplitude, instead of our regular amplitude being at positive 1, we're going to switch it to be 1/2. So that's going to change this to be 1/2, keeping this at 0. This then it becomes negative 1/2, staying at 0 and at positive 1/2. Then we're going to take a look at our period. Instead of being a period of our normal sine or cosine function at 2 pi, we're changing it to 2. So we're simply dividing everything by pi. So this is going to be 0, 1/2, 1, 3 over 2, and 2. Then what we need to take a look at is what kind of other transformations we have in our graph. Now you'll notice that if there was a horizontal shift, we would have our b would be out front, which is pi, and then in parentheses we would have x minus h. Well, we don't have an h, it's 0. So there will be no horizontal shift on this one. Also notice that the leading coefficient, 1/2, is positive. So there isn't, a is greater than 0, it's not less than 0, so there will not be a reflection. So the only thing we need to worry about right now is the k is equal to 3, which makes that a vertical shift of positive 3. So what we're going to do is simply move our entire graph up 3 units. So instead of starting at 1/2, we're going to be at 3.5. And then we add on 3 units to each of these, shifting everything up 3 units. And then we can go ahead and graph from there. So when we graph, we'll be at 1, 2, 3 units, and we will be at 0, and we'll be at 1/2, and positive 1, and 3 over 2, and positive 2. 2, 3, and at 4. So when we graph our function, we're going to start at 0 and we'll be up at 3.5. And then at 1/2 we're going down to 3. And at 1 we're going to be down to 2.5. And then we'll be back up to 3 and then back up to 3.5. And so we have our cosine function. Arrows on both ends. Alright, let's move on to our next example. Okay, in this example, we have y is equal to 4 sine 3 x plus pi over 3. So the first thing we want to do is take a look at our amplitude. Remember, our amplitude is the absolute value of a, and in this case our amplitude then is going to be a positive 4. Then we'll take a look at our period. Remember, our period is 2 pi divided by the absolute value of b, and in this case our b is 3, so our period will be 2 pi over 3. Next, we're going to take a look at our horizontal and our vertical shifts. First of all, our vertical shifts. If we had a vertical shift, we would have plus some value, which is our k. And since we don't have a k value plus 0, there's not going to be a vertical shift this time. However, in our format, this would be x minus h, and h value gives us our horizontal shift. Since our sign has changed from minus to a positive, that means that our shift is going to be a negative pi over 3, and that's what we're going to do shifting horizontally. So let's take a look first at our 5 key points that we would graph in our standard function. So remember that we have 0, we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. And with our sine function, we start at 0, 1, 0, negative 1, and back to 0. So the first thing we're going to do is we're going to change our amplitude. So instead of being an amplitude of 1 unit, we're changing it to 4 units. So we're still at 0, but we will be at 4, 0, negative 4, and 0. So we've changed our amplitude to 4. We don't have any other shift vertically because there is no k. So the next thing we need to do is to change our period. So our period is going to begin at 0, and we're going to finish at 2 pi over 3, which means we're going to divide all of our sections by 3 in order to break up that period. So dividing by 3, which is the same thing as multiplying by 1/3, we have pi over 6, we have pi over 3, and then we have pi over 2. Okay, Then our horizontal shift says that we now need to move our entire graph to the left or subtract pi over 3. So we could do that simply on our graph, or we can change that in our table. So we're basically going to subtract pi over 3 from each of these. So 0 minus pi over 3 is going to give us negative pi over 3. Pi over 6 minus pi over 3 is going to give us a negative pi over 6. Pi over 3 minus pi over 3 is going to be 0. Pi over 2 minus pi over 3 is going to give us pi over 6. And 2 pi over 3 minus pi over 3 is simply going to be pi over 3. So when we graph, we're at 0, 1, 2, 3, positive 4. And the negatives will have negative 1, negative 2, negative 3, negative 4. And then we need to make our markings for our horizontal. So we'll make this at negative pi over 6 and negative pi over 3. And then we'll have positive pi over 6 and positive pi over 3. And then we can go ahead and graph our sine function. So we start at negative pi over 3 at 0. At negative pi over 6, we're up to positive 4. We're back down to 0 for 0. Then we're going to go down to negative 4 at pi over 6 and back up to 0 at pi over 3. And that's going to be our sine function, which has stretched vertically quite a bit from 1 unit to 4 units, and the whole entire graph has shifted over to the left, as well as our period becoming shorter. Let's take a look at our next example. So y is equal to negative cosine of 4x. So the first thing we're going to take a look at is what is the amplitude of our function. Remember, our amplitude is the absolute value of our a. So the absolute value of negative 1 would be positive 1. Then we'll take a look at our period. Our period in this case is 2 pi divided by the absolute value of b, which is 4. So our period in this case is going to be pi over 2. Now notice in this case, we do not have anything being added on. There is no plus k in this instance, so there is not going to be our vertical shift. And notice that there is no h value inside the parentheses, so we're not going to have a horizontal shift. However, you do see that our leading coefficient is negative, a is less than 0, so we are going to reflect this, and this time because we are having y is equal to k as being the line that we're going to reflect over, since k is equal to 0, we're going to reflect that over the x-axis. So let's set up our points that our 5 key points that we're going to graph. Okay, first of all, our amplitude is at 1. So with the cosine function, remember we're at 1, 0, negative 1, 0, and positive 1. Our period regularly is at 0, pi over 2 for our basic function, pi, 3 pi over 2, and 2 pi. However, when we are going to graph this new function, we have changed that to be pi over 2 as our length of our period. So we're going to put that as pi over 2, and then we're going to have to divide each of these by 4 in order to find our new points. So when we divide them by 4, we have pi over 8, pi over 4, and 3 pi over 8. Okay, so we'll put those on our graph. So we have 0, and then we have pi over 8, pi over 4, 3 pi over 8, and pi over 2. And we have positive 1, and we have negative 1. However, we need to reflect our graph over the the x-axis. So when we do our reflection, what we want to talk about is instead then of starting at positive 1, we're going to reflect that and it's going to be at negative 1. Still be at 0. Then instead of negative 1, we're flipping it over to the top, which would be at positive 1. Back to 0, and then instead of positive 1, we're reflecting that over, so it will be at negative 1. So basically, we have turned our cosine function upside down with our negative leading coefficient. Let's take a look at some other examples. So can we actually write equations now doing the opposite by using the information given to us? So we have y equals 1/3 cosine of 2x, and we want to shift this graph up 4 units. When we shift it up 4 units, that's the k value that's being affected, the vertical shift. So we simply write the same function, y equals 1/3 cosine of 2x, but we add on, so we put plus k, and since it's up, it will be a positive 4. Next, we have the graph of y equals 8 sine 1/2 x, and this time we want to shift 4 units to the left. So we have y equals 8 sine of 1/2. And remember, when we're shifting left or right horizontally, that is going to be our h value. So we have to put x minus h, but because we want it to be negative, minus a negative would give us plus 4. And that tells us then that would be 4 units to the left. In the last example, the graph of y equals 2/3 cosine of 3x reflected over the x-axis. Now when we're reflecting it over the x-axis, the first thing we need to remember is that is going to be making our leading coefficient negative. And since we want it over the x-axis, that means our k has to be 0. Because the equation for our x-axis will be y equals 0, and in this case we don't have a k, so we are just fine. So we'll have y equals negative 2/3 cosine of 3x. Let's take a look at a more complicated example. In this example, we are going to have several things that we need to do. The first thing we need to do is to make sure that our equation is written in the correct form. You'll notice that the b has been distributed inside the parentheses. We need to factor, or maybe a not correct mathematical term would be to undistribute. We need to pull that 4 back outside of the parentheses to bring the b outside. So we're simply going to divide each of these by 4 to bring that b back outside. So we have y equals negative 3 sine of 4. And then it'll be x minus pi over 4, and then minus 1. So what we want to take a look at then is our k value is equal to negative 1. That means we are going to shift our graph eventually 1 unit down. Then our h value affects our horizontal shift, and it's x minus h, so our horizontal shift is going to be pi over 4. Next, we want to find the amplitude. The amplitude in this case is the absolute value of a, so our amplitude is going to be positive 3. Then we want to find the length of our period, which will change, but for now, remember it's 2 pi divided by the absolute value of b, which is 4. So that's going to be pi over 2 to begin with before we do any of our other shifting. Alright, so let's write down our standard function, y equals sine of x. So again, we begin with 0, pi over 2, pi, 3 pi over 2, and 2 pi. And since we're dealing with the sine function, we have 0, 1, 0, negative 1, and back to 0. So we need to start doing some of our shifting. Let's begin with our amplitude. So the first thing we need to do is to change our amplitude so it reflects that we are going to have an amplitude of 3. Remember, amplitude is the distance from the center either up or down. The next thing that we need to talk about is that our amplitude is going to be affected by the K value, and this is going to shift vertically, and it's going to do it -1 or 1 unit down. So we need to change all of our values to reflect or to show that they're going to shift 1 unit down. So we'll subtract 1 from each of these to go 1 unit down. Okay, so that is our amplitude. Now we're going to go over to the period, and the first thing we want to do with the period is that we need to make sure that we understand that our period now is pi over 2. So we start at 0. Our length needs to be pi over 2, which means we have to divide all of these by 4. So this is going to be pi over 8, pi over 4, 3 pi over 8, and pi over 2. All right, next we need to shift horizontally a positive pi over 4. That means we're going to add pi over 4 to each of these values to shift it to the right. So this becomes pi over 4. When we add pi over 8 to pi over 4, we're going to get 3 pi over 8. Then we're going to get pi over 2. Then we're going to get 5 pi over 8. And then we're going to have 3 pi over 4. Okay? All right. So we're going to set up our graph. So we are at 0, 1, 2, and -1, -2, -3, -4. Okay. Then we want to set up our x-axis, our horizontal axis. And we want to go by eighths actually to make our units even. So this is going to be pi over 8, and then we have pi over 4 where our graph is going to begin, and then 3 pi over 8, pi over 2, 5 pi over 8, and 3 pi over 4. All right, so now we'll begin to graph. However, what we need to remember is that we also had a negative leading coefficient. So when we have the negative leading coefficient, that means we want to reflect our graph over the line y equals k, which means that's going to be y equals -1. So we need to reflect our graph over -1. So we're going to make a dotted line going across here so you can see that this is where we want to reflect our graph. So let's pick a different color. We'll pick black. We're going to start with -1 being at pi over 4. Okay? Then at 3 pi over 8, we are supposed to go up to 2, which is 3 units above. However, because we want to reflect that, we're actually going to go 3 units below, and we're going to go down to -4. Then we're going to go back up to -1, and now our 5 pi over 8 is supposed to be 3 units down to -4, but we need to reflect that, so we're actually going to go up instead to +2, and then we're going to go back down to -1. So instead of going up and then, down and then up and then down, we're going to go down and then up. We're going to do the reflection. In review, please make sure that you remember that our vertical shift is affected by the K, the horizontal shift is affected by the H. If our a value is less than 0, we need to reflect our graph over the line y is equal to k after we have taken care of the vertical and horizontal shifts. And then be sure to rewrite the function if it needs to be in the correct form, which is these. So if the b has been distributed, make sure that you factor or take the b back out.